Okay, you may remember my 8-bit CPU. I've decided to dismantle it because I need the breadboards for some other projects that I'm going to do later. I've got here a timer that's based on a 555 timer to give me a clock, which only runs at about 30 or 40 hertz, not megahertz, I think. Another bit I want to keep is this, which is will display 8-bit into decimal. So I programmed that, and I want to keep that one because I may have use for that later. So these two components I'm going to leave as is. I'm not going to dismantle them. I want them to stay. And then there's one other piece of this assembly that I want to keep. I'm going to actually two, because I'm going to keep this breadboard wire. It works really well, and it keeps it acts as one wire, so it cuts down the resistance and things when you chained up breadboards like this. So I'll keep that as well. But the other thing that I really want is the other timer, which I've been using. So I've got a 1 megahertz clock crystal here, and I cut it down so that it was I think I cut it down by 3 or possibly 4, and I built a stop on here as well, so that I could stop the timer, and I could single step the timer as well with this clock. So this will be very useful for my next couple projects, because I actually need a clock that runs faster. So a 1 megahertz clock will be very, very useful for me. So this board, only the sort of left hand side of it is the clock and the clock functions. The rest were some IC pins to keep logic, but I only want the clock half, which is the sort of left side of the breadboard. So the chips on the other side really are redundant, so I'll just remove all of those. Now, the projects that I want to work on, I do need breadboards, and I didn't really want to spend the money to get more when I've got these here. And I haven't really used this CPU as much as I thought I might. And in addition, it doesn't work quite the way I want. It needs to be redesigned. So I thought, why not just dismantle it, and then later I'll put it back with some new design ideas that I've discovered since I started that particular project. I think I can do a lot better, and I think I need more registers for a start. Ideally, I would like to make a 16-bit CPU rather than an 8-bit CPU. So that's a project I might start at some point later when I got a bit more time. But at the moment, I need the breadboards more than I need the CPU. I haven't actually worked on it for a long time, and I haven't used the assembly program that I wrote in Rust, or the assembler that I wrote on Rust, for a while as well. So I want to change the CPU. I want to do a different design. I think I looked at doing a pipeline CPU, but I don't think I'll do that. But I do want a 16-bit one. And if I do a 16-bit CPU, then I don't really want to use breadboards. I will probably actually get circuit boards made and printed. I'll buy the chips and print the circuit boards and solder them all up, but I'm going to need an air solder gun, all sorts of stuff. So at the moment here, I'm just disconnecting all of the control lines, all of the various bus wires, and everything. So I'm just going to pull it all apart. This bit is all of the power rails for the breadboard, which were stacked together to be used as a bus, a data bus. But I'm going to pop them all apart and put my breadboards back the way they were originally when I got them. Now, some of the projects I'm going to use these for are for CPUs, which are probably 100 times more powerful than this thing I built. And they're single CPUs. I've also got some other chips, which I'll show you later, that aren't CPUs, but are more powerful than any of this. But those are the things I want to use in my new projects. So I'll speed this up in a minute to just basically show me dismantling it. I've got a lot of chips. I've got some foam, basically anti-static foam for a lot of this, and I'm going to have a lot of wires left over, but it's fine because I'm going to need these wires later, so I'm just sticking them all in there in the bucket at the moment, and then when I need them again I can pull them out, chop them up and use them. The processor, the way it was, some of the problems that I had with it were the instruction set. I didn't like the way that it worked. The logic unit that is just above where I'm working at the moment wasn't really set up properly, and it didn't do all of the logic functions that I wanted. It did do XOR and OR and a few of the others, but it only did it on one data bus, so the sort of B register data bus. And what I really wanted to do is to be able to work on either set of registers, so regardless of which register, that it could do the logical operations. Now there are chips that you can get that will do that, and then it would only have been one chip rather than the 8 that I've got here, but I probably will just use these again, but configure the logic and the assembly to actually make better use of those chips, so that either set of data buses could use them. Anyway, but that's for the future. That's another future project when I'm got a lot more time on my hands, like when I had, the COVID lockdown, which is when I did the vast majority of this. The other thing I want to change is, if you look at the right hand side over there where I'm not working, the little ROM chips, I've got some newer ROM chips that are read-write, electrical read-write, rather than I don't need to use a UV lamp to erase them, because I was struggling with the UV lamp. I was having to use a UV dental cleaning thing to basically erase it, and it took about 5 or 6 hours to erase the chip. So I've got some electrical ones, electrical read and write, so none of the UV stuff, and it'll make my life a lot easier. So I'll use those in all my future projects, but I've only got a limited amount of those. I've only got 2 or 3 of those, so I might wind up using these for some other stuff. And actually these have a lot more pins, so they do come in quite useful, these longer ones. Now, a lot of the design here did work out very well, and a lot of the things I will carry over. So having buses for register use that are independent of the data bus itself was very useful, so that you could, transfer directly from register into memory without using the data bus, or transferring from the register into the logic or the calculation unit without actually, or into the ALU basically, without needing to go through the data bus to use the ALU. that was very good, and very useful. So I learned a lot while I was doing this particular design, and I learned a lot about what I don't want it to do. But yeah, those ROMs that I was showing you there, I'll probably be replacing those in future with electronic read-write ones. It's just so much quicker to use. I had actually considered just using RAM chips, to be honest, because I can write those just as easily using like an Arduino and a breadboard. So I could write the thing rather than use the ROM programming device that I have. So I can write to RAM, and they would be just as efficient and probably quicker, to be honest, than these ROMs. But you know, we'll see. Those are sort of design decisions that I'll need to make when the time comes up. But you do need a lot of breadboards. If you're going to do this sort of stuff, you're going to need a lot of breadboards. And the problem is that they stay here and you can't reuse them. So you have to pull your CPU apart, as I'm doing here. And although it's probably only taken me a half an hour to pull it all apart, it took me 3 or 4 months to put it all together, and that's a lot of work and a lot of hours. But I think next time, start with a design in mind, which I didn't here. I basically was building it and sort of changing it as I was building it. So next time I will have a design in mind. I might simulate it using some software before I start to build. But yeah, definitely have a plan in mind next time before I start building. These breadboards are okay. They're all sort of cheap breadboards, to be honest. They're not the most expensive you can buy, but they were pretty good. I've got them all on Amazon, and I think they cost me about £12, British pounds. So they weren't really that expensive. You get like 3 in a box. So you can spend a lot of money on sort of gold-plated ones, but I didn't need any of that, and I didn't really have any problems with my breadboards when I was doing the CPU electrically. It worked out fine, no issues, especially after I made that single cable USB power. So I did have some issues when it was just the breadboard chained to the next breadboard to the next breadboard to the next breadboard, because you were going through a lot of connections, whereas once I'd soldered that single wire up, it was so much better. So here I've got the new CPUs, the new projects that I want to sort of start to work on, and the reason I needed the breadboards. So what we got here is I've got a MK or a Motorola 68K. So this is a 32-bit processor, and this thing is way more powerful than all of that stuff on the breadboard. So one breadboard, lots more power. I've also got a Z80 CPU that I want to start doing some stuff with, just playing around with really. I've got an assembler for all of this, so it's not a problem. And here's a 6502 CPU as well, which you kind of can't see, but it's a 6502. So I've got the 6502, the MK, the M68K, and this is a AT128. So this is an AT Mega 128. So it's basically the same chip that you're going to get on the older Arduinos, and it has its own registers and everything, so it's way more powerful. So the thing at the top is more powerful than any of the others, and it's the smallest, but it's also the newest and most modern. But these are the things I'm going to start to use.